Hey everyone! In this video I'm going to give you some tips to get started with your first assignment. In this assignment we're going to replicate some figures in Penny 2016. That article is titled Chilling Effects, Online Surveillance and Wikipedia Use. And specifically the is analyzing to what extent the revelations or the publicity or publication of surveillance practices of the NSA changed people's behavior in the sense that traffic to privacy-sensitive Wikipedia articles was reduced potentially after those revelations. Okay. Specifically for this assignment, your task is to replicate two plots. One is figure 2 in the original article that is here on the left, and then figure 4a, which is two subplots right here. And I'm not going to talk too much about the details of the paper or these specific figures. Essentially, what you'll need to do is you'll need to extract traffic data trends on how many users accessed certain Wikipedia articles over a period of about 2 or 2.5 years. And there are a couple of different ways to do that, and there are a couple of challenges. And so I just want to give you the opportunity to get started on that. One option that you have that is kind of the easier option to get these data on Wikipedia traffic is using the Wikipedia trend package that is available in R. And so I'm not going to talk too much about that because I know some of you have already kind of started exploring that package. Just to get everyone up to speed, it's fairly straightforward. If you load this package, what you can do is you can use the wp_trend command to directly extract trends of user access statistics for specific websites. And in the paper, you have a list of, at least for the main analysis, of 48 kind of security related or privacy sensitive related Wikipedia sites that are included in the analysis. And so basically what you'll have to do is get the trends for all these articles and combine them, and then create averages for each month from the time from January 2012 to December 2014. So you have kind of enough time before and after this cut point of June 2013. So this is fairly straightforward. The challenges here are, of course, you can include multiple websites here in this argument instead of just one. This is just a Wikipedia article on Al-Qaeda, but you can include the remaining ones on terrorism and so on here as well. The other challenge then will be to summarize all the views, the page views across pages, and then since these are daily statistics, you have to then summarize them by month. Which you can do using, if you want to do it using the tidyverse, using group by and summarize. This will be fairly straightforward. The first thing you have to do though is to kind of extract, since this is daily date, these are daily, or the date format is year, month, day. You kind of have to figure out how to transform this so you have a year, month information, and then you can group by that year, month variable, and then go from there. In order to group this by year, month, you could either kind of try to transform this as a string and then kind of cut off the day information. Or if you look in the Wikipedia trend function package, there's a function in there as well that allows you to directly extract that information. So it should be fairly straightforward. However, if you have any questions or problems, we can talk about that in more detail in the Q&A session next week, because you'll still have another week before you have to submit your assignment. What I wanted to talk in a little bit more detail, though, is the second option, and that's kind of the manual way of collecting these data without the Wikipedia trend package. And that's a little bit more work, but it will also be a good learning exercise. So to the extent that you're kind of already completed this exercise using the Wikipedia trend package, I would encourage you to kind of try out the second option, because even though it will take a little bit more coding and a little bit more time, you will directly learn a few more techniques for web scraping, and I think that will be a useful exercise. So what is the second option? The second option is to directly download the data, these data from the wikimedia.org website that is listed here, that is also listed in the assignment. And specifically, we will use, as I will show, we will use a package called rvest, which is also part of the tidyverse, which is a package that gives you some web scraping abilities, and we will use that package to kind of extract the information or download the underlying data sets from this website. Okay. So how are we going to do this? The first thing we want to do is we want to actually look at this website, and I'm going to click on this now, and let's see. So this is the website that shows the page view statistics for Wikimedia projects in general. So not only Wikipedia, but it contains that information as well. And so if we want to download the same data that I just showed you to download with the Wikipedia trend package, we have to go through a couple more steps. First, we want to kind of read through this website and kind of look at the information, because they provide you with some overview of how this information will be is stored and how you can actually access it. Okay, so there's a little bit of information on how these data are organized, and I'm going to go back to that in a second once we figured out how to actually download it. Okay, and now remember, we want to download data for 3 years, 2012, 2013, 2014. And so the first thing we're going to do is we're going to click on 2012, and we'll see, okay, if we go to that site, we have a couple of additional links for each month. And if we click on January for that month, we'll see that there are actually quite a lot of kind of compressed data files available. The difference from the Wikipedia Trends package is that here we actually have hourly data for clicks on each package. Okay, and so this is quite a lot of data sets that are actually quite large. Okay, so of course, in this case, this is just for January of 2012. These are way too many data sets to manually download them all, unpack them, and then extract the information. So we need some kind of way to do this automatically. All right, and so this is a relatively simple website that actually makes that fairly easy for us. Okay, so now I'm gonna just go through the steps on how you could get that started with one of those data sets, just for one website. And then if you kind of want to go that route, you can kind of think about ways of scaling that up. You'll have to write some loops to get more information about all the websites for all the for the entire timeline, essentially, for the entire time period. Okay. All right. So the first thing that I'm going to do if I want to start working on this is I'm going to go to our RStudio Cloud shared workspace, and I will just open our problem set 1, and I'm just going to work in that problem set 1 as well. And so the code that I will write here will be added to that problem set, so later you can also access that code right away. I hope this doesn't take too long now to resume this project, and we'll see how that works. All right, so this is our workspace with the problem set. We have the R Markdown file that contains the instructions for the problem set. You can also directly look at the PDF, and the link for the raw data is also included here. Okay. So what I'm going to do, when you submit your response, you can directly kind of edit this R Markdown file to write up your own response. But for now, I'm just going to work in an R script and just work on that. And then later on, I might add it to an R Markdown file. But for now, the R script will be sufficient. So the first thing we want to do is, of course, we want to load the tidyverse. Actually, let me, and then also load rvest. Okay. And then I'm gonna run this code. And one of the key functions that is part of the rvest package is read HTML. And read HTML allows you to directly read in an HTML, a website essentially, and read in the information that we want to extract. Okay. So ultimately, what we'll want to do, if we go back to our dumps.wikimedia.org, what we'll want to do is we will want to access each individual page that has that lists the data files that we want to download. We want to go through kind of the list of all these index pages, and then download each individual data file, extract the information that we want to keep, and then go to the next one, essentially, right? So in order to kind of loop through those, one thing to note is that there's a clear structure in the web address to access each year and each month. And we see the folders here are page counts -raw 2012 /2012 for January 2012, right? So we will use these in order to access each month of 2012, 2013, 2014 to kind of get at each of those websites that ultimately have the data sets that we want to download. Okay, so essentially, I could directly, if I wanted to look at February 2014 or something like that, I could directly put that in here, and I would get to the right database, essentially. Okay. All right, so now focusing on January 2012, the first thing we want to do is we want to, I'm going to call this object links. and we want to use the read HTML function to read in that specific website that again has the page views for 2012 January on an hourly basis for each day of that month. Okay, so if we look at this, this is just basically the HTML information of the entire website. And of course, that page itself has a bunch of other stuff. And ultimately, all we want is the links to these specific page count data sets. Okay. So in order to know how to extract that information, we can use another command. And I'm going to just use the pipe here. And that is HTML nodes. Okay. So what does HTML nodes do? HTML nodes helps us extract specific identifiers, specific kind of parts of an HTML website. Okay. And in order to know which part you want to extract, one way to do this in any browser, I'm using Chromium, but in any browser, you'll have an option. If you right click, you can look here at inspect. This gives you some information about how kind of the underlying HTML website is structured. Okay. And I'm just going to look briefly here. One of the things to notice is that we have this CSS or this indicator for links, and then href, that's the basic HTML command for a link. Okay, so in order to now select this part, because the link is ultimately what we're interested in order to select that part, all we have to do is, again, we're using the pipe, so we read in the entire HTML file, and now we want to extract the HTML node li, which is the link, which is, again, if we go back here, the link information or kind of the link section that is included in that website. Okay. Now, if we just run this, then the result will not be just the entire website like here. Ultimately, it's just what is called an XML node set, and it includes all the links and or all the kind of link tags, li tags, and the href, so the actual HTML link. Okay. So we're not actually interested in the li or all the HTML stuff, right? So in order to extract that, all we have to do is we use the HTML nodes command again, and now select the A. So that's just selecting the identifier for the link itself. And now if you look at the result of that, we see now basically we just selected this internal part here. That is now the result of our selection of the HTML node A. Okay. So now we still want to go a little bit further because ultimately all we need is this specific name. We don't need the href and the actual link ID. So in order to select that, we can use HTML. And if we do this, now we kind of thin this down to only the underlying links to the data sets. Okay. So we have now page counts 2012 January 1st, and then this is the identifier for each hour. And of course, you know, you could kind of make an argument, well, we kind of directly know what the, you know, date structure is and what the hour structure is. So theoretically, we could just write up a loop with that structure, but, you know, in a lot of cases, maybe the data is more messy or maybe it doesn't follow this neat structure. So going this route is more flexible, essentially. All right. Another thing to note is once we have this list, one thing to note here is that there are two types of statistics that are listed in our website for January 2012. We have page counts, and if we go further down, we have actual project count files, which is kind of aggregates, not for the specific pages, but for the specific wiki projects. And we're not interested in the page counts, okay? So if we just want to get rid of those, oopsie, what we can do is we can just subset. This is now a vector, a string vector essentially, and we will just subset the string vector and only focus on page counts. So this will now only include elements of the string vector that includes page counts. Okay. So now what we have is a vector. And if you look at that vector, this is now, these are now the names of all the data sets that are included, all the page count data sets that are included in the January 2012 web page, okay? And of course we can automate this for, you know, all other, let me go up. Write a loop for 3 different years and for every individual month, and that will give us a link of all the project counts, page counts. Yeah, the project counts was the previous call. All the page counts that we're interested in, right? So now we have the collection of all the links of the data sets that we want to download. Okay, that's already a huge help. We don't have to manually download all these data sets. By clicking on them, we can now directly tell R to download these data sets. All right, and this is what I'm going to show you next. Specifically, the way we're going to do this is we will create a temporary file using the temp file command. Okay, this will just create a temporary file because these are so many files essentially. We don't want to, you know, download each file and keep it because this is just going to, you know, blow up our hard drive. We'll go through the step by step, create a temporary file, download the data, just select or extract the information that we really want, and then remove or delete the temporary file or override it with a new temporary file. Okay. So after creating this connection to a temporary file, sorry, I shouldn't use the keyboard so much. I will use the download file command. And now there's a combination of 2 different things that we need to do. We know, I mentioned earlier, we know the structure of the website to access the kind of web page for a year and a given month, right? Remember, this was up here where I talked about 2012 and 2012-1. So this is kind of the first part to access the data set. I'll put this here. And we want to combine this with individual elements of the links that we extracted in order to, you know, be able to tell our download this specific data set that is at this, you know, specific address online. Okay. And in order, the way to combine these 2 strings is using the paste command, and specifically paste 0, because we kind of just want to attach them to each other, and paste 0 is a shortcut, so there's no additional character that would be put in between. And paste 0, the first part is the main address of the website, and the second part would be link, and we can just do this with the first element of link. All right, so what happens if we execute this? Oops, oh, I called it links. It gives us a new string down here that is now the complete address of one of these data sets. Okay, if I plug in this data set here, if I open this in a browser, it will directly download this data set. Okay, this is equivalent of clicking on this link. All right. Of course, we could do this for multiple links. Our links list is longer, and then we would have, as you can see here, 3 different addresses that you can directly access to download the data. For now, we'll just use one. Okay. So I will use this as the address of the file that we want to download. And I will save this in our temporary, in the connection of the to the temporary file. Okay. So now I'm gonna run this and then run this. And now we see here that R is downloading the data set that is identified by this address, and save it as a temporary file. Okay. This is a .gz file, so this is kind of a compressed file that we can't directly, we would have to unpack it. We can unpack it with the gz file command. Again, we're now unpacking this temporary file. And I will add an option that this will be, it will be kind of unpacked as a read-only text file. All right, so now we have a connection to this temporary file, which is just a text file that is read-only. Okay. All right. So now after we have done this, we can actually extract the data that we're interested in. Okay. And I'm going to call this df, the data frame. The first thing we want to do is we want to now read in our temporary file. So when we use the download.file and unpack this file, it's not directly loaded in our R workspace, right? So it's just, we told R to download this file, put it somewhere in a temporary folder, and now we have to kind of add it to our current environment. And so we do this using the read.table command of our temporary file. And then, because we know the way this file is structured, if we go back to each of these data sets, if you read through this text, basically contains one row for each observation, for each page, and has some identifier to kind of to identify what part of or what Wikipedia project it's associated with, and then it's the name of the page, and then it's the count of access, or the access count, and the last number is the size of the website, okay, or the size of that page specifically. And so ultimately, the important thing is that this is just kind of a text file where each piece of information is separated by a space. So in order to read that in, we want to use the read.table command, and we tell R that the individual variables are separated by a space, just an empty space, okay? And then one thing that I'm going to do is I'm going to directly convert this into a tibble. And maybe we can just look at this right away. Why not? This might take a little while. I hope it won't be too long. All right. So we now see we have 2 million observations, 4 variables. This is the identifier that I mentioned. This is the page title, the number of clicks, or the number of page views, and the page, like the size of that website. Okay. So in order to now, of course, this is way more information that we want. Ultimately, we're only interested in Wikipedia pages, English Wikipedia pages, and only specific sites. Okay, so just the same way we selected them using the WP_trend command. Okay, so in order to get that information here, we can use the filter command, and all we want to do is, on the one hand, only identify English Wikipedia pages, and that's quite easy to do by just selecting EN here for V1. That's the identifier of the specific Wikipedia project. And then for V2, this is the name of the page, and this is where in the first example that I showed you, we just looked at Al-Qaeda as the underlying, as the Wikipedia page that we want to look at. Okay, so if we now, I should just select this with my mouse. If we run all of this again, and look at this file that we get. It's basically only a 1x4 tibble with now the number that is interesting to us is here, V3, the number of page views, 123. Of course, this is not the same number as in the WP_trend command, because this is hourly page views, which could be interesting in case you're interested in more short-term changes in another project or something like that. But of course, ultimately what you'll have to do is run this for every hour, for every day, combine them all together, and also combine them not only for Al-Qaeda, but also for the remaining 47 pages. Okay, so as you can see, it's a lot more work. It takes a lot of time because you ultimately have to download a lot of data that you're not quite interested in, and then just select the information that you want, and then I should include this to now delete the temporary file again. And ultimately, if you are comfortable with writing loops, it would be relatively straightforward to scale this up to kind of loop through all the possible months, then loop through all the possible website or all the possible websites for a month in a given year, and then through all the available data sets only the page views, of course, the page counts, of course, and then selecting all the information and then aggregating that up. And in theory, you should arrive at roughly the same information, of course, that you have with the Wikipedia Trends function. So of course the Wikipedia Trends package is much easier in this case, and it provides you kind of the monthly statistics right away. But this is kind of a good learning exercise in case you want to, or you're interested in getting into some more advanced web scraping and things like that. Not every piece of information that is available online directly has a package in R available where you can extract the information in a nice format like with Wikipedia Trends. So if you want to practice that, I encourage you to kind of try to set that up with RVest and directly download these data from this website. All right, so this was my first direct live coding attempt for our lecture videos. So I hope this was useful. I also included, let me go back to our slides. I included the code here in the slides as well. You'll have access to it on RStudio Cloud as well. So if you have some time and if you're interested in web scraping, give this a try. See if you can make it work. Maybe not the entire time period. It might take too long to download all the data sets and everything. But play around with it a little bit. It'll be a good learning experience, I think. And oops. All right. That's all I have for this week. I'm looking forward to our next Q&A session, and I'll see you next Wednesday.